today we are going to learn about completing the square. Completing the square. And completing the square deals with binomial squares. We're going to utilize that characteristic of binomial square. What does a binomial square look like? Well, this is a binomial that has squared. And can we recognize what it looks like as a trinomial and be able to go backward? So what are the characteristics of a binomial square? Remember, it has three terms. Second sign is positive. You take half of b and square it, and it equals your c value. That's sort of part of it. There's a couple. Remember, there are four characteristics. A and c are perfect squares, square root, 2ac, etc. But that's not, that's factoring. So we just want to know, how can we recognize the relationship between these two values? And if you take half of b and square it, it'll equal c. That is the important thing. So if I give you something like this, x squared plus 8x plus, let's say 11. Is this a binomial square? Is it a binomial square? No, it's not a binomial square. How do you know? Well, because if you take your b value, divide it by 2, and square it, it should equal this value, and they aren't. So we know that this trinomial cannot produce a binomial square. That's all we need to do is check. Can we recognize? The next question would be, all right, now that you recognize whether it is or isn't, let's do another little trick here. What if I have, what would I need my constant or my c value to be in order to make this a binomial square? What's that constant have to be? Well, you would take half of 10 and then you would square it. So if this value was 25, then yes, it would be a binomial square, and that would produce this. So not only do we have to recognize when it is or isn't, but then if we're given these two terms, do I know what constant value I would need in order to make the rest of that expression a binomial square? So we get a problem like this, and we say, is the left side of this equation a binomial square? And the answer is no, it's not. So what we have to do is, all right, since this value here doesn't make this part of the equation a binomial square, let's get rid of it. Let's move it to the other side, which would create v squared plus 2v equals 3. Now, let's look at this and go, all right, what value do we want to be added to those two? Well, if I take half of 2, which is 1, and square it, that equals 1. So if I had that, that would be good. So I'm gonna add 1 to that left side. In order to balance the equation, I have to add 1 to the other side. Now, this is good. We like this. This gives us v squared, whoa, that was weird, v squared plus 2v plus 1 equals 4. Now, we see that this is a binomial square, so we can factor that. And that equals the quantity, not x, the quantity of v plus 1, quantity squared, equals 4. So I turn that in. This value is always going to be half of b. That's a nice little cheat code, as I called it. It's a nice little efficient way of knowing what you're going to produce inside that binomial, or what those binomials can be. All right, now we're at the point where we have to solve for the variable. we can't get to that variable yet because of the parentheses, and the parentheses are representing that square. So what gets rid of a square? A square root gets rid of a square. Good. So if I take the square root of a square, those are going to cancel, and it leaves me with v plus 1. Now, whenever I take the square root of a variable being squared, I need to introduce plus or minus. And the reason behind that is if I have a variable that's being squared, if I put 5 in for the variable, 5 squared is 25. If I put in -5 for that variable, that also produces 25. So we see that that variable can be either plus or minus, which will produce that same value. So whenever I take the square root of a variable being squared, I have to do plus or minus on the other side. So that is going to become plus or minus square root of 4 is 2. So we have v plus 1 equals plus or minus 2. Now we're still solving for the variable v. What's happening to it right now? 1 is being added to it, so I'm going to do the inverse of that. And that gives me v equals -1 plus or minus 2. And I can write two statements from that. I can do -1 plus 2, and I can do -1 minus 2. -1 plus 2 is 1, -1 minus 2 is -3. So my solution is -3, positive 1. And this specific part right here was completing the square. I found the constant that would make this a binomial square. So this is a technique in order to solve for the variable. When we look at this original problem, we can't solve for v, we can't isolate it because you've got a v squared and a v. They don't combine, you can't just solve for one of them. So it's impossible for us to isolate that variable in the traditional solve for the variable techniques. So one of them is by completing the square. And that's what we did here, is we completed the square and then we solved for the variable. Because notice when it's in this form, there's only one variable. And once there's one variable, we can use the inverse operations to help us isolate it. Let's look at the next one. All right, so first thing, is this a binomial square? No, it is not. So I need to get rid of my constant. I need to move it over to the other side. That leaves me with p squared minus 8p equals 20. Now, we look at that b value. I'm going to take -8. I'm going to take half of it, and then I'm going to square it. So that is the value that would make it a binomial square. And we need to remember that what we do on one side, we have to do to the other. So this is now a binomial square on the left side, so I can write it as a binomial square. Remember, this value is always going to be, it's going to come from here. It's going to be half of my b value, equals 36. Now, I'm going to solve for the variable. I'm going to do the inverse of squaring. The inverse of squaring is square rooting. And whenever I take the square root of a variable being squared, I need to introduce the plus or minus. Whoops, didn't mean to do that. Let's use that eraser. So these will cancel. The square and the square root will cancel, and it leaves me with p minus 4. We get plus or minus the square root of 36 is 6. And now we're going to isolate p. We're going to get rid of that -4. And that leaves me with p equals 4 plus or minus 6. 4 plus 6 and 4 minus 6. 4 plus 6 is 10. 4 minus 6 is -2. So my solution is -2, 10. Now, if we saw this, and remember this is a secondary, let's copy this. This is a secondary technique. You had already learned a technique earlier in the year. Remember when we used to factor in order to do solutions. So the first thing Is there a common factor amongst those? No. Is it dead on the street? No, it's not two terms. Is it a binomial square? No, we know it's not a binomial square. We already tested for that. Can we use A times C? Yeah, A is 1, C is negative 20. Let's find factors of 20, or 1 and 20, 2 and 10, 3 no, 4 and 5. Signs are different, and the bigger is going to be negative. Negative, negative, negative. Signs are different. So 1's positive, negative. Negative 19, negative 8, negative 1. Which one's equal to my middle? Negative 8. So this becomes p squared plus 2p minus 10p minus 20 equals 0. We're going to factor by grouping. We're going to factor out a p from the first group. We're going to factor out a negative 10 from the second group. We see that we did it right because we have p plus 2 in parentheses in both of them. When we take that out, that leaves us with p minus 10. And remember, why we like this is because we're going to use the zero product property of zero. Zero product property? I don't know. Two numbers that multiply to make 0, we know that one of these two has to be equal to 0. So we set each one equal to 0 to find out what that value of p would be in order to make that number equal to 0. When p is equal to 2, when p is equal to 2, that makes 0. And then add 10, p equals 10. And when p is equal to 10, it makes that right number equal to 0. So my solutions are negative 2 and 10. Hey, I've seen those values before. I've seen those solutions, negative 2 and 10. Yeah, it's the same. It's just using a different technique. All right, this is completing the square. This is factoring and setting it equal to 0. The reason why we have different techniques is because certain ones are going to be easier than others. Let's look at this question. This one, we're still using completing the square, but when we have completing the square in this one, we notice that my b is an odd number. So the odd number is going to be more challenging when you take half of it. So first question I ask, is it a binomial square? No. So I have to move that negative 30 over. And that leaves me with a squared minus a equals 30. I'm going to take, here's my b value, I'm going to take half of it, and then I'm going to square it. And that gives me 1/4. So I'm going to add 1/4 to both sides. Now this is a binomial square. How do I know? Because I completed the square. So I know that it's going to be a minus 1/2. Remember, this is always going to be that value. It's always going to be half of my b value. Quantity squared equals, now I got to add those two together. So 30 plus 1/4. Well, I got to turn 30 into fourths. So 30 over 1 equals how many fourths? 120 fourths. So I got 120 fourths plus 1/4. I don't want to keep it as a mixed number. It's going to make it hard when I have to take the square root. So that's why I didn't make it 30 and 1/4. Right? So I just didn't combine that whole number in the fraction, because I need to have it be an improper fraction, or at least a fraction. So that gives me a minus 1/2 quantity squared equals 121 over 4. Okay, now we've completed this square, and now I have to solve for the variable. I got to get rid of that radical. Now remember, with radicals, when we have a fraction in a radical, when they're being divided, I'm allowed to put them under their own houses. So I can separate those radicals. That's not a bad thing. All right, so square root of 121 is 11, square root of 4 is 2. So these cancel on the left side. You're left with a minus 1/2. And then we get plus or minus Square root of 121 over 4 is 11 over 2. And now let's again isolate my variable. We get a equals 1/2 plus or minus 11 halves. So we're going to write two equations, 1/2 plus 11 halves and 1/2 minus 11 halves. That gives me 12 halves, or 6. This gives me negative 10 halves, or negative 5. So my solution is negative 5, positive 6. We're always going to write those in numeric order, from least to greatest. All right, let's do this one. Let's have this be a you try. So take a moment. Let's try this one and see what you think of it. See if you can do this. What do we notice about our b value is odd, so that's going to be a little bit more challenging. It's not as easy when it's even, but we're still going to apply the same technique. So pause the video. When you're ready, unpause it and I'll explain the solution. All right, first question you ask is this a binomial square? It is not. So I'm going to subtract 12 from both sides in order to get my first and second terms. Drawing colors that I'm not being consistent with. And now we want to complete the square. So I'm going to take my b value, I'm going to divide it by 2, and I'm going to square it. That gives me 49 fourths. 49 fourths plus 49 fourths. That does not look like a 9. There you go. Now, we know that this is now a binomial square, so that becomes x plus 7 halves quantity squared. Hopefully you remember this is just half of b. We like it as an improper fraction. It's going to be easier that way. Now we have negative 12 plus 49 fourths. Let's turn 12 into fourths. That gives you negative 48. Now we get 1/4. So when we combine those, you get 1/4. Let's take the square root, plus or minus. You get x plus 7 halves. This also shouldn't be intimidating because that radical is just going to cancel with the square. That's why we did it that way. We love that technique. It makes it easy. And then plus or minus the square root of 1 over 4. So the square root of 1/4, square root of 1 over the square root of 4. Square root of 1 is 1, square root of 4 is 2. Let's move that down. So we get plus or minus 1/2. Let's subtract 7 halves. Let's isolate the variable x. You get x equals negative 7 halves plus or minus 1 over 2. Let's do two equations from that. Negative 7 halves plus 1/2. Negative 7 halves minus 1/2. So that gives us negative 6 halves, which is negative 3. This gives us negative 8 halves, which gives us negative 4. So my solution is negative 4, negative 3. Love it. All right, those are 4 examples. Hopefully, the difference between those, the first two, your b value was even, which is a little bit easier. You don't have to deal with fractions. And then the second two problems, your b value was odd. And that makes it a little bit more challenging, but you're still applying the same exact steps. Come and see me. Let me know if you have any questions. Good luck.